How does data transform in classification algorithm feature space? Imagine trying to sort a jumble of different objects into neat groups. Now picture turning that messy pile into a clear map where each item has a specific spot. That's what happens when data transforms in classification algorithms. In supervised learning, raw data like images, text, or sensor readings first become numbers, called feature vectors. Each feature vector is like a set of coordinates that shows where the data point sits in a multidimensional space. This process begins because raw data isn't always easy for computers to understand directly. For example, a picture might be represented by pixel brightness values, while a document could be turned into word counts or word embeddings. These numerical representations make it possible for the machine learning model to analyze and compare data points. Sometimes, the original feature space makes it hard to tell different classes apart because data points from different groups overlap or are not linearly separable. To fix this, algorithms often apply transformations that map data into a new space. This new space is usually higher in dimensions, which helps make the classes more distinct. Think of it like stretching or twisting a tangled ball of yarn into a straight line so you can see the pattern better. Support vector machines are a good example. They use something called kernel functions to implicitly transform data into higher dimensional spaces. Kernels like polynomial or radial basis function kernels help turn complex, nonlinear relationships into straight lines, making it easier to draw a boundary that separates different classes. These transformations can be explicit, where new features are created by combining original ones, or implicit, where the math does the work without actually creating the new features. This transformation process is key because it allows classification algorithms to find decision boundaries that clearly separate different groups. When data points are mapped into the right space, the model can classify more accurately. This idea is behind many AI tools like ChatGPT, which understand language, or image generators like DALL-E and Midjourney, which categorize and generate complex visuals by representing inputs in rich, multidimensional spaces. It's also important to think about ethics here. How data transforms can influence model fairness. If the transformation emphasizes biased or irrelevant features, the results might reflect or even worsen those biases. That's why transparency about how data is transformed and used is so important when deploying AI in real-world situations. In short, data transforms in classification algorithms by turning raw inputs into numerical feature vectors, and then often mapping those vectors into new, higher dimensional spaces. This process helps models find clear decision boundaries, making classification more accurate and reliable across many AI applications and productivity tools.